Every year El Nino develops, you'll hear people say the same thing. Well, hurricane season should be quiet this year. And I've even said something along those lines. But to be honest, that's a major oversimplification. And El Niños don't just affect hurricane season. They can reshape weather patterns across the globe for months, affecting everything from tropical cyclones to even our winter weather. Today, I want to explain what El Nino actually is, why it usually suppresses tropical cyclones in the Atlantic basin, but also why major hurricanes can still occur in El Nino seasons. I also want to explain the effects that an El Nino or Super El Nino could have on this upcoming winter. This should be an interesting one. Let's break it down. Most people know that El Nino has to do with warmer water in the Pacific Ocean. But how does this actually happen? Under normal conditions, easterly trade winds blow from east to west across the Pacific Ocean, carrying with them a lot of warm surface waters out towards the Western Pacific. Now, over time, this can actually make these sea levels in the Western Pacific several inches higher than they are in South America, as this warm water begins to pile up. But during an El Nino, those trade winds weaken. Without those strong winds consistently pushing that warm water towards the Western Pacific, gravity begins to pull that water back towards the Central and Eastern Pacific. And as those waters further back east, towards North America and South America begin to warm, something very important happens. The warm water begins to heat the air above it. In these areas, an abundance of warm and moist air begins to rise up into the atmosphere, producing more moisture and tropical convection over areas of the Pacific that typically aren't as active. Now here's where, at least in my opinion, it begins to get even more interesting. When you move one of the largest sources of tropical heat on the globe thousands of miles to the east, the atmosphere responds. Jet streams shift, pressure patterns change, and storm tracks move. Weather changes across much of the globe, including right here in North America. One region that feels these effects almost immediately is the Atlantic hurricane basin. So why does warming waters in the Pacific Ocean thousands of miles away affect hurricanes in the Atlantic? The answer is convection. As I said, as those waters in the Pacific warm, more thunderstorms develop near the equator in the central and eastern Pacific. All of that rising air has to spread outward once it reaches the upper atmosphere. That process strengthens the subtropical and tropical jet streams that stretch eastward across the Caribbean and portions of the tropical Atlantic. And those stronger upper level winds increase something called vertical wind shear. Vertical wind shear simply means winds that change with speed and direction as you move up further into the atmosphere. And hurricanes absolutely hate vertical wind shear. And really any wind shear in general that they're not producing themselves. If you think of hurricanes like a vertical tower, they want to stay stacked as they are moving across the ocean. What vertical wind shear does is it begins to push the tops of these towers off of our hurricanes or tropical cyclones. This begins to tilt our tropical cyclones, making them much less vertically aligned. As this happens, circulation weakens and thunderstorms become displaced. This makes it much harder for storms to strengthen into a hurricane. And if it's already a hurricane, well, usually this leads to some pretty rapid weakening, depending of course on the intensity of the wind shear, but typically, especially in a strong El Nino year, you can get some pretty serious wind shear out there in the Atlantic basin. And this is why on average, El Ninos produce fewer Atlantic hurricanes. Not because suddenly the ocean becomes too cold, but because the atmosphere becomes much less favorable for them to stay organized. Now here's the part many people don't realize. El Ninos don't completely eliminate hurricanes, it just stacks the odds against them. Wind shear isn't constant, it changes from week to week. Sometimes the jet stream shifts a little bit to the north, and sometimes upper level winds briefly weaken. Sometimes a pocket with very low wind shear begins to develop over some very warm waters. And if a tropical disturbance happens to be moving into one of these regions during this favorable window, it suddenly has everything it needs: warm water, moist air, low shear. And that is when rapid intensification can occur. The perfect example, Hurricane Andrew in 1992. There was a decaying El Nino in 1992, and that year only produced 7 named storms across the Atlantic basin. Yet one of those storms became one of the most devastating Category 5 hurricanes in American history. That's why it's important to understand that a quieter season doesn't always mean a safe season. Now, taking a look at our current conditions this year, one thing that's hard to ignore is how warm the Western Atlantic basin is. Water temperatures across portions of the Gulf, Caribbean, and Western Atlantic are running well above average. And water temperatures are the most important ingredient when talking about developing tropical cyclones and strengthening hurricanes. At the end of the day, hurricanes are basically gigantic heat engines. They thrive off of deep, warm water. Think of the ocean as the hurricane's fuel tank. Warm, deep water is basically unlimited fuel for a hurricane or tropical cyclone. So while an El Nino can increase the wind shear across portions of the Atlantic basin, it's not making the waters in the Gulf, Caribbean, or portions of the Atlantic any cooler, and it's definitely not making the waters any more shallow. Remember, hurricane season isn't just controlled by one ingredient. It's a combination of many different ingredients that ultimately determine the outcome. So what about winter? This is another area, and I'm guilty of it, where El Nino can get oversimplified. Generally speaking, El Nino strengthens the subtropical jet stream, and a stronger subtropical jet stream sends more storm systems across the southern US. As a result, and I'm sure you could guess, but the southern tier states generally, during an El Nino season, experience more cloudiness and more frequent storms. Because of this extra cloud coverage, and because precipitation and evaporation cool the air around of it, a process known as dynamic cooling, temperatures across the south during El Nino winters typically on average run a little bit colder than normal. But here's something that's very important to understand. This is usually a wet cold, not an Arctic cold. The atmosphere is cooler because it's more cloudy and rainy, not because there's a deep, cold Arctic air mass diving down into the south more consistently. That's why an El Nino doesn't automatically mean more snow for the south. Although for areas at elevation across the south, it does typically mean a little bit more snow. Areas that are naturally cooler at those higher elevations are going to be fed a lot more moisture typically. The good news is, as we know, El Ninos can provide excess moisture for the south, especially off the Gulf at times. And a couple, if not more, deep Arctic outbreaks are almost guaranteed every single winter. And you have increased odds for there to be moisture for that Arctic air mass to tap into across the south during an El Nino year. This is the reason some of the south's biggest snow and ice storms have occurred during El Nino winters, when that moist and cold air happened to line up at just the right time. One last thing to remember, no two El Ninos are alike. The strength of the event, where the warmest Pacific waters are located, and other climate patterns like the Arctic Oscillation or AO, North Atlantic Oscillation or NAO, Pacific Decadal Oscillation or PDO, and Madden-Julian Oscillation or MJO, can all influence how our winter eventually unfolds. And I look at all of that when I put together my way too far out winter forecast, which I'll probably be releasing in a few weeks, maybe the beginning of August. So yes, El Nino usually does reduce the amount of Atlantic hurricanes, but it doesn't eliminate them. It doesn't even guarantee a quiet season, and it certainly does not mean we can let our guard down. El Nino also sets the stage for our winter, influencing where storms track, how much moisture moves across the south, and whether that moisture eventually meets Arctic air. Weather is rarely controlled by just one pattern. It's the interaction of dozens of different pieces of the atmosphere working together. That's what makes meteorology so fascinating and also so difficult. If you enjoyed this deep dive and want more videos like this breaking down the science behind weather and not just my typical forecasts, be sure to subscribe and let me know down in the comments. And as always, I appreciate you watching this video, and I'll see you in the next live stream or in the next video. See ya.